Which of the following most correctly depicts a step in the reaction of chlorine with methane in the presence of sunlight? Before moving forward, we will quickly go through the reaction mechanism. In the presence of light, chlorine molecules undergo homolytic cleavage and they converted to chlorine free radicals. The next step is chain propagation, and this involves several steps. First, the CH bond of a methane molecule undergoes homolytic cleavage and it converts to the methyl free radical. During the process, HCl molecule also produced. Next, this methyl free radical reacts with the chlorine molecule and converted to an alkyl halide. During the process, chlorine free radicals generated. These are the other possible steps of the chain propagation. During these chain propagation steps, always these alkyl halides react with chlorine free radicals and they converted to the respective carbon free radicals, and during the process HCl molecules are produced. And the other type of reaction is these carbon free radicals react with chlorine molecules and they converted to the respective alkyl halides, and during this process chlorine free radicals generated. The final step is chain termination. During chain termination, these free radicals react together and converted to the products. These are some of the possible reactions of chain termination. Two chlorine free radicals react together to form a chlorine molecule. Methyl free radical can react with a chlorine free radical and produce CH3Cl. Then two methyl free radicals together can form an ethane molecule. Now we will go through the answers. Chain initiation step needs energy. In the presence of sunlight, these chlorine molecules undergo homolytic cleavage and converts to chlorine free radicals. In this chlorine molecule, two electrons have been shared between the two chlorine atoms, and when this molecule undergoes homolytic cleavage, this bond breaks and each chlorine gets one electron. Therefore, one chlorine molecule converts to two chlorine free radicals. This homolytic cleavage is represented by these half arrows. Now we will check the first answer. The first answer looks like the chain initiation step, but these arrows are not correct. Therefore, the first answer is not correct. During chain propagation, these methane molecules react with chlorine free radicals. During this reaction, this covalent bond between the carbon atom and the hydrogen atom breaks down, and this methane molecule converts to the methyl free radical, and these two atoms together forms HCl molecules. Always these half arrows indicate the homolytic cleavage. Second, third and the fifth answers are about the first step of this chain propagation. Answer 2 is not correct. There is no reaction like this. The third answer looks like this step, but these arrows are not correct. Therefore, third answer is also not correct. The fifth answer, methane molecule always react with chlorine free radicals. Therefore, fifth answer is also not correct. This shows the correct step for this reaction. Always, methane molecules react with chlorine free radicals and they produce methyl free radicals and HCl molecules. Now we will see the second step of the chain propagation. During this step, methyl free radical reacts with chlorine molecules and they produce chloromethane and chlorine free radicals. During the process, this bond undergoes homolytic cleavage. Always in this mechanism, we have to use half arrows. This second step is given in the fourth answer. Therefore, answer for the question is number 4. Now we will see a quick method to get the answer. This question is about the reaction of chlorine with methane in the presence of light. This reaction involves free radicals, and always the arrows we use in the mechanism are half arrows. Therefore, you can remove the first and the third answer. The reason is these arrows are not half arrows. During the reaction, methane molecules and the produced alkyl halides always reacts with chlorine free radicals. Therefore, you can remove the fifth answer. When methane molecule reacts with a chlorine free radical, this carbon hydrogen bond undergoes homolytic cleavage. Therefore, second answer is also not correct. So the correct answer is number 4.